Okay, today's lesson is talking about the z-scores and how they relate to percentages under the curve. Okay, so here's the question. What percent of the data is below the z-score, negative 1.96? So this is what it looks like. So I'm going to show you two methods here. Method one is by hand. Okay, so in this method you would go to a chart. Okay, and you would look for negative 1.9 and go over to the 6. So right there, you can see that it's 0.0250. Okay, so that's what we have found. So that means that 2.5% of the data is below that. Okay, method two is in your distribution function. So you're going to push second function bars, distribution, and down to number 2, normal CDF. And when you type it, you always say what's the furthest left to the furthest right, comma, and then the mean and the comma, the standard deviation. Okay, so if I'm saying to the left of it, the furthest left is negative infinity. So negative, and then 999999999. That's negative infinity for us because we can't do infinity. Comma to negative 1.96. So I want to go below that. Comma the mean. So on a normal curve, your mean is 0, and your standard deviations are 1, right? So comma 0, comma 1. And you get 0.025 essentially. Okay, they're going to be a little bit different because this has to get rounded. Okay, next. What percent of the data is above the z-score 1.15? Okay, so our chart always gives you to the left. So we're going to look up 1.15. So you find your chart again. So 1.15, 0.8794 or 49. So that's what I have here, 0.8749. So here's your z-score of 1.15. That means that 87% of your data is below you. So I have asked for above. So what I'm asking for is actually that piece. So you do 1 subtract 0.8749. And so this is 12.5% of the data is above you. Okay, in your calculator, distribution, number 2, normal CDF. Okay, so now we're going left bound. So that's 1.15, that's the furthest left, comma, the highest, infinity, comma 0, comma 1. So mean standard deviation. And there you go, 12.5% of the data is above you. Okay, next, so we're going to go backwards now. What z-score corresponds to having 40% below it? So now, this time, you're looking for, in your chart, how much has 40% below it. So when you have your mean, 50% is below you. So to say something that you have 40% below you, I know that my z-score is going to be over here, right? It's not going to be over here because this is going to be over halfway. So this is what we're trying to find. So you go into your chart and you try to look for something that is close to 0.4. Okay, so we're down here. So this one is 13 away. So this one is closer than that one. So negative 0.25. So negative 0.25 is the z-score. Okay, now when you look this up in your calculator, you're going to go to distribution. You're going to go to inverse norm, and you're going to type the percent below as a decimal. 40% below. So this means what z-score has 40% below it, and it's negative 0.25. Okay, what z-score has 10% above it? So if you think about where it would be located, this is what you're trying to find. 10% above what z-score? So I know it's way over there, right? Our calculator in our chart is not going to do the above. So it always talks about what's below. So if 10% is above you, what's below? So 90%. So again, on your chart, now I know I'm on the positive side. So I'm looking for a 0.9. What's the closest to 0.9? This one right here, that's closest to 0.9. That's closer than that. So 1.28. So 1.28, that one's the closest. Okay, so again, we would go to distribution, inverse norm, but I have to type the percent below. So 90% below, obviously as a decimal, 1.28 is the z-score. Okay, next. Given a mean of 160, standard deviation of 4.2, what percent of the data is above 150? Okay, so just a visual. 160 is here. So 150 would be, so we go down 4.28, so 150 would be quite down there. And we're trying to figure out the percent above it. Okay? Okay, so method 1 by hand. We're going to have to calculate the z-score. So we do the score minus mean over standard deviation is negative 2.38. So negative 2.38 is 0.0087. Okay, so that's below that. So if I do 1 minus 0.0087, I get that 9913. Okay, so does that make sense why I have to subtract? So 99.1% of the data is above. So on our calculator, I don't have to do any z-score conversions. So this time I'm going to go to distribution again, down to number 2. So left bound, right bound, comma, mean, comma, standard deviation. Okay, so above 150, so I'm going to go 150, comma, to infinity, comma, and now I'm not going to go 0 and 1, I'm going to do 160, comma, 4.2, mean, comma, the standard deviation. 99.1% of the data. Okay, given a mean of this, standard deviation, what percent of the data is between 125 and 130? Okay, so I'll show you again by hand. I'm sure by now you're going to start to realize the calculator's faster. Okay, so what I'm going to do is going to get the z-scores, so now we know how to do that. So 125 minus the mean over the standard deviation. Okay, I'm going to look that z-score up, negative 1.58. Okay, so I look up negative 1.58. Okay, and now I also do the same thing with 130, get a z-score, 1.05. Now I gotta go look up 1.05. Okay, so I have those. So now it means, so here's your mean. So it means that at a z-score of 1.05, 85% is below you. Okay, and at negative 1.58, the percent below you. Okay, but I want to know the percent between them. So can you see I would take this value and subtract that value? Okay, so we'd subtract the 2, 0.85, and get 79.6%. Okay, obviously this is going to be way faster in the calculator. Distribution, CDF. So lower bound to upper bound, so between 125 and 130. The mean, the standard deviation, and there we have it. 79 point, well this would go to 7. Sometimes they are just a decimal off. And that's it.